Thanks everyone for joining this session. My name is Vikas and I'm a Principal Solution Architect at AWS. In this session, we are going to walk you through how realestate.com.au, also known as REA, has achieved operational excellence in managing thousands of stacks by means of infrastructure as code and automation. We are fortunate to have REA's lead architect, Dan Aragao, and technical lead, Thomas Janoski, with us here today. Thanks, Dan and Thomas, for joining us. This is a level 300 session, so we expect that you have some understanding of AWS services like virtual private cloud, CloudFormation, identity and access management, and Amazon EKS, which is a managed Kubernetes service. Let's start by defining infrastructure as code, what this means and what problem it solves. Infrastructure as code is a mechanism of managing and provisioning application infrastructure through the definition files, mostly written in either YAML or JSON. It allows you to maintain a single source of truth of your application's stacks and to replicate or redeploy them easily and confidently to other environments like dev, QA, and prod. You can also maintain history and versioning of your stacks so that you can audit and roll back changes to the previous state if required. It also supports automation through CI/CD pipelines. AWS CloudFormation and AWS CDK are the two native ways to implement infrastructure as code on AWS. Infrastructure as code is one of those topics that always comes up in my discussions with customers. Especially for SysOps admins, managing it at a scale is a real complex task. The complexity moves a few notches up when admins have to manage thousands of stacks in 180 plus multi-generation AWS accounts, having 400 plus VPCs in them and 1,000 plus microservices running in there. To know how REA manages such complexity, we requested Dan and Thomas from REA to join us in this session and share their secret recipe, which enables them to manage thousands of CloudFormation stacks without causing disruption to their production services. So, without much further ado, I invite Dan and Thomas to take us through REA's journey of achieving operational excellence.
Thank you, Vikas. I'm very happy to be here with you. And as Vikas mentioned, my name is Dan Aragao. I'm the lead architect for REA. And one of the main reasons why I'm happy to be here is because it is an opportunity to share. And one of the great things about our industry is that we love sharing. We love showing what we have learned and how we can actually progress our profession and solve the problems together. So I'm very happy to be here. And let me walk you through what we're going to be talking about today. I'm going to open up with some of the challenges in the landscape in REA, some of the caveats of the solution that we have devised. We're going to talk a little bit about how we evolved REA-CoPilot as a product. Then we're going to have an overview and the design of REA-CoPilot. Then we're going to get into a demo so you can see it running in action. And then we're going to have a deep dive to talk about one particular aspect of the solution that focuses on IAM roles and everything that we do to keep it secure. And finally, some takeaways and the lessons that we have learned. So this is REA's landscape. We are a big company. We have a lot of people coming to our websites and apps every month. We roughly see 60% of the adult population of Australia visiting us. And that creates a lot of data. We have roughly over 2.5 billion clicks, taps, and swipes in every interaction with our users. And to be able to cater for all of that demand, we have many systems. We have over 1,200 services and microservices. We have many commercial products. We have over 190 AWS accounts, and some of them are as old as 12 years. So we've been in this journey with AWS for a long time. VPC is a virtual private cloud. Think of it as a virtual data center. And to make all of this technology go, we have about 62 pizza web and mobile teams. A 2-pizza team is roughly 8 to 10 people. So you buy 2 pizza and then you can feed your team. Now let's have a look at REA's operational challenges. Some of these challenges are historical. We have grown as a company through extreme autonomy. Teams were allowed to choose their technologies and how they were going to implement it. Another aspect that we had to tackle is DevOps. We had an unwanted side effect of succeeding at creating a DevOps culture, which means that in REA, the teams that develop the systems, they carry the pager. And they are the only ones that usually would make changes to production environments. So there wasn't really an appetite for a centralized team to actually go and make changes to their environments. So we had to overcome that trust. Another situation that came from that misaligned autonomy was the sprawl of technologies. We have everything under the sun, ranging from CloudFormation to Ansible to Terraform, homegrown solutions, CDK. And what that causes is not just a lot of time being used to maintain these solutions, but also a lot of cognitive overload for SysOps admins because they need to know all of the different ways of maintaining different systems for different teams, which creates little reuse. If we have different solutions, it makes it really hard for us to actually have something that looks like something else, which in its turn creates another problem, which is when teams have to share how they solve problems, or when you have people going from one team to another, they feel like at times they're actually changing companies, when in reality, they're just changing a team. In this session, we're going to talk to you about how REA has achieved operational excellence. And the main way that we actually do that is probably focusing on the last bullet point on the right side, which is all about happiness. We really aim at having people that come to work and they're happy with what they're doing. And SysOps admins, they're really not keen on doing repetitive manual work. And for us to be able to achieve that and get people happier, we are going to see how we leveraged infrastructure as code, how focusing on optimizing solutions for a company level rather than a team level helped us in that journey. We're going to see how establishing stable abstractions and well-defined interfaces allow for us to progress CoPilot as a product and deliver the best solutions. And we're going to see that a good product, it's all about great engineering. You need to have engineering finesse and do things properly to be able to achieve the outcomes. So finally, we're going to have a go at seeing how we can change and roll out changes more easily, how we reduced barriers to adoption, because you really don't want to devise a solution where you're going to be able to move portions of your systems and you're going to have that long tail of unfinished migrations. That was not success for REA. We wanted to be able to roll out a new solution and not leave anything else behind. So if you heard what I said and you got excited about it and you're saying, well, yes, these are problems I want to solve. I have this situation in my company. I just want to put a little bit of a caveat here and try and walk you through our journey. So the first thing is that you need a strong business case to land something like that, especially because this is imminently a technical endeavor. This is something that will support your systems and you're going to allow to move faster, but at the same time, it doesn't necessarily drive any revenue coming through the door. And one of the things you need to do is have a very strong, compelling case to be able to get the investment that you need to roll out the solution. And one of the best ways to do that is by clearly identifying what are the benefits that you're going to be unlocking with that solution. The capabilities and what you're going to be able to do and how you're going to foster that adoption will allow you to create that business case. And finally, a word of caution around keeping your costs under control. And the solution you're going to see in here, it's actually the result of a focused and deliberate investment in creating that solution. So good engineering actually requires investment. So my advice to you is that don't expect that you're going to be able to do what we are showing to you in here with about 0.3% of a SysOps admin working here and there. That's really not the case. You need to have your investment in place so you can achieve the same results. Now let me tell you a bit of the story about how we evolved REA-CoPilot over the last 12 months or so. In REA, we have a principle that if we can buy, we prefer to buy because software development is really expensive. And building your own solution from scratch, it's ideally not the best thing to do. I would say that most companies are in a similar situation. So we started off by running several experiments and investigating AWS's excellent services that try and achieve the same thing. So we had a look at Control Tower, we had a look at AWS tech sets, and unfortunately, because our own unique set of requirements, we couldn't use them straight out of the box. And these requirements were mainly because we do have way too many heterogeneous environments. Because we've been in this cloud journey for a long time, we do have something called cloud legacy. Not a lot of companies can claim that. And the final aspect is that we wanted to be able to maintain our stacks in a way that it would allow us to maintain these services. They aren't necessarily just AWS. So we have services like PagerDuty, Splunk, and others that don't necessarily live in AWS. And that was another unique environment that we wanted to cover with CoPilot. So because of these reasons, we decided to build ourselves a new one. I'm going to hand over now to my colleague Thomas, that's going to take you through what CoPilot is and the details behind the solution.
Hello everyone, my name is Tomasz Janowski. I'm a tech lead at REA working on the CoPilot product. In REA, we often use an analogy of cloud service marketplace when we talk about CoPilot. It's a marketplace where SysOps admins can choose services that CoPilot will manage in their accounts. Any team in the organization can become a service provider and scale out their local solutions to all the other AWS accounts. That approach allows us to scale the expert knowledge of our sysadmins. That knowledge is codified inside CoPilot Service Operators. A CoPilot operator is a piece of software that performs deployment, monitoring, and ongoing support of a service. REA-CoPilot is a platform that our SysOps admins use to install services in their AWS accounts. Currently, CoPilot offers services such as CI agents, log aggregator, secure VPCs, or AWS console single sign-on. Following the infrastructure as code approach, system administrators describe the desired services and their configuration using YAML files that are then uploaded to CoPilot. The CoPilot service operators are responsible for the actual deployment and monitoring of the services in all REA AWS accounts. Now let's have a closer look at the design of REA-CoPilot. REA SysOps admins occasionally receive requests from a product team to deploy a new CI agent or to configure log aggregating infrastructure. They also perform tasks such as setting up access to the AWS console or create a new VPC. In order to complete any of those tasks, a SysOps admin creates a CoPilot YAML file that contains the configuration of the service, such as account number, region, and any specific details depending on the service itself. The YAML file can be uploaded directly to CoPilot control plane from a terminal. But because we follow the infrastructure as code and GitOps approach, we keep all the CoPilot YAML files in a Git repo, and we let an automated CI job upload them to CoPilot. Once the YAML config file is uploaded to the control plane, the operator starts performing an action. Operators are simple applications that continuously watch for config changes in the control plane. They are responsible for deploying a single CoPilot service in AWS accounts. Typically, the operators manage CloudFormation stacks created from an embedded template. Stack parameters are derived from the config stored in CoPilot. In REA, we run service operators on ECS with Fargate in accounts owned by the service providers. Operators could also be deployed to EC2 or Kubernetes pods. Different service operators share substantial amount of boilerplate code and config, so we created an SDK that simplifies, speeds up, and brings consistency to the process of building new operators. It takes about a week to create an operator for services that are not overly complicated. Let's now focus on the CI agent operator in the middle of the slide. I'm going to switch to a demo showcasing that operator. So this is CoPilot YAML manifest file for CI agent. We have the service type, the name, account ID, and how many gigs we want to have on the CI agent. I'm using REA-CoPilot CLI tool to apply that YAML manifest to control plane. I can use the tool to display all the details about newly created CI agent. The status summary says in progress. That means that the CI operator is now performing an action on that resource. That action is basically deploying a CloudFormation stack, which is now in progress. After a while, the CloudFormation stack will be deployed. I will quickly check the auto-scaling group that's part of the CloudFormation stack. From here, I will select my EC2 instance because I'm just going to double check that the instance has 50 gigs indeed. Yes, that's correct. On the CI admin page, I can see my newly created agent. It's green, ready to accept work. And the CLI tool is showing the summary status as complete. Now I'm going to show you how I can quickly make a change to the build kite agent that I just created. I will upgrade the disk size from 50 gigs to 100 gigs. That change is being stored as a Git commit in our repo because, as I mentioned before, we follow the GitOps approach. The change is being applied to the control plane. If I have a look at the details, I will see that the status summary has changed from complete back to in progress. It means that the operator picked up that change and is now trying to deploy it. As you can see, the stack was in the update status. Finished. It's now complete again. If I go and select the new EC2 instance, I will see that the disk size has been changed to 100 gigs. CoPilot CLI tool will also show us that the status has changed back from in progress to complete. In the next scenario, I'm going to roll out a change to all the CI agents managed by CoPilot. I'm upgrading the CI software version to the latest one and raising a pull request for the CI operator project. Someone from the team will review that pull request and merge it. In the meantime, I will use REA-CoPilot CLI tool to display all the agents, all the CI agents that are managed by CoPilot. So as we can see, there are plenty of them. Let's grab by complete and count the total number of instances. We have 169 instances. In the meantime, the pull request was merged and I have now the new version of the operator running in production. If I have a look at the list of CI agents again, I will see that some of them have changed the status from complete to in progress. It means that CoPilot operator running with the new version number is now trying to upgrade all the stacks at the same time. We can see that at the moment 56 stacks are being upgraded and that number is going up, 106. So as you can see, the majority of stacks have changed from complete to in-progress state. They're all being upgraded, and after a while, we have all the agents running the latest version. So we have, again, 169 agents in complete state. The CI admin page is now showing that all the agents that we have deployed with CoPilot are running the latest version, 3.27. So with a very small change to the config file in our CI operator repo, I was able to roll out the mass upgrade of all the stacks managed by CoPilot. Before I continue talking about CoPilot and how it solves the problem of privilege escalation, I would like to do a quick overview of IAM Boundary Policies, which CoPilot leverages to ensure that IAM roles created by its operators are protected from privilege escalation. A boundary policy is similar to IAM policy. It allows us to define a list of statements with allowed actions against resources in multiple AWS services, and then attach it to an existing IAM user, an IAM group, or a role. The effective policy of the entity with the boundary policy attached will be limited by the policy specified in the boundary. It's a very useful tool for implementing privilege escalation protection. Now let's explore the architecture of CoPilot from the angle of least privilege access paradigm. How do we ensure that service operators don't get elevated permissions? So, we start again with our SysOps admin, who is asked to deploy, let's say, a log aggregator service in a new AWS account. In step 1, the admin creates a YAML config file for the service and uploads it to CoPilot. In step 2, the service operator that watches for any changes in CoPilot control plane discovers the request for a new log aggregator instance. It checks if the deployment IAM role is available in the target account, but at this stage, the role doesn't yet exist. So the operator sends a request to control plane to create that role. In step 3, there's the AWS Access Operator, which is an internal component of the CoPilot platform. It picks up the IAM role request, and in step 4, deploys it to the target account. The AWS Access Operator has a trust relationship with all AWS accounts onboarded to CoPilot. It assumes the CoPilot main role, which provides access to creating deployment roles for all CoPilot services. The AWS Access Operator also creates a boundary policy that specifies what resources the service should have access to in order to work properly. The deployment role itself includes the policy required for an operator to deploy the stack. In step 5, the service operator tries to deploy the log aggregator instance again. This time, the deployment IAM role exists, so it can assume it, and in step 6, it creates the CloudFormation stack for the log aggregator. The operator is allowed to create IAM roles for resources such as Lambda function. A special IAM statement in the deployment policy ensures that any IAM role created by that operator must have the boundary policy attached. The boundary policy itself has exactly the same statement, so that makes it impossible to escalate privileges. That's all from me. I will now hand over back to Dan.
Thank you, Thomas. And as I mentioned to you before, one of the key aspects for us was to not leave any migration unfinished. So I just wanted to show you this graph that covers what has been the adoption of CoPilot in REA so far. And you can see as the graph grows that we started to establish more trust, and suddenly it really took off. Teams grew in confidence and trust in CoPilot, and now we have actually moved the dial and we have thousands of stacks being managed by CoPilot. And I like to see this as our SysOps admin happiness curve, because in the end, as you can see, less manual work makes people much happier. Now let's talk a little bit about the lessons we have learned rolling out CoPilot over the year or so. One of the key things is identifying the right tech and the investment that you need to make. Making sure you have that strong case, understanding what are the benefits you are unlocking, go a long way. Something that is fundamental in REA for us is the fact that we treated CoPilot as a product. And I don't say that lightly. I mean it in a way of applying systems and product thinking to delivering solutions. In REA, as the lead architect, I can tell you that we do not mandate teams to use a particular type of solution. They are entitled still to choose what they want to use to solve their problems. So CoPilot fundamentally has to compete with every other product out there. So teams need to see it as the best thing that they can possibly use. And over time, with a great product, trust shows up. People believe that the product is good and it does deliver what it says on the tin. Another aspect that was fundamental for us was the ability to allow for the company to move. We know in REA that things are never going to stay the way that they are currently. Changes are constant. Teams are changing names. Reorgs are happening all the time. So CoPilot needed to find a way to allow for the organization to move freely. So name spacing is fundamental. Being able to actually segment how you do things in CoPilot and still allow teams to change shape went a long way. Alongside with that, to be able to compensate for the cognitive overload, is defining a language that people understand. Ubiquitous language and calling the same thing all the time, everywhere, goes a long way in allowing for people to change teams and still understand what they're doing. And finally, everything infrastructure as code. I cannot emphasize that enough. If it's not in Git, if you can't track who made a change when, it's not worthwhile doing, because that's not going to take you to a place of automation and operational excellence. So I thank you very much, and I'm going to hand over now to Vikas that will bring us home. Thank you.
That's awesome. Thanks for sharing. Before we conclude the session, being REA's solution architect, I would like to share my view of REA's journey in context of REA-CoPilot. They started from what SysOps admins were doing to manage a huge number of stacks and worked backwards from there. They achieved operational excellence by means of automation and using infrastructure as code as a first-class citizen for deployments and by adopting that GitOps approach. They tried out a number of experiments and failed fast to find the most feasible solution to the complex problem. Here are the additional resources if you would like to learn more about services and frameworks that we have covered in this session today. If you would like to learn more about how to design, deploy, and operate your infrastructure and applications on the AWS cloud, these resources provide materials for learning and certificates. Thank you for watching. If you enjoyed this video, don't forget to leave feedback.